Stirling engine, presented by Team ChEver. Outline. History. What is Stirling engine? Main components. Working principles. Types of Stirling engine. Efficiency. Pros and cons. Application. Conclusion. History. Robert Stirling was the father of the Church of Scotland. He invented the Stirling engine in 1816 to replace the steam engine. Stirling engine is a device that converts heat energy to mechanical power by alternately compressing and expanding a fixed quantity of working fluid at different temperatures. Working principles. The basis for the Stirling engine is same as the internal engine. Compression occurs at low temperature and expansion occurs at high temperature of a confined. However, the conventional engines burn fuel internally and intermittently, while Stirling engine burns its fuel outside the engine itself continuously. Therefore, Stirling engine is considered as external continuous combustion. One side of the engine is continuously heated, while the other side is continuously cooled. Air moves to the hot side where it is heated and it expands pushing up on a air moves through the regenerator to the cold side where it cools off and contracts, pulling down on the piston. Temperature change inside the engine produces the pressure change needed to push on the piston and make the fuel do not enter to become the working gas. Cyclic flow or working fluid within the engine is achieved through accomplish thermal regeneration since an intermittent flow heat exchanger stores a large portion of heat of the working fluid after expansion and subsequently returns it to the working fluid after. Types of Stirling engine. Two-piston mechanism, the alpha type. Piston displacer system, beta type. Two-piston mechanism. There are two cylinders. The expansion cylinder is maintained at high temperature, while compression cylinder is cooled. The passage between the two cylinders contains radiator. Types of Stirling engine. Piston displacer system, beta type. Main components. Power piston, which is a small, slightly steel piston that moves when the gas inside expands. Displacer is very loose in its cylinder so air can move up and down easily between heated cooled types of Stirling engine. Piston displacer system, beta. There is only one cylinder, hot at one end and cold at other end. A loose fitting displacer shunts the air between the hot and cold ends of the cylinder. A piston at the other end of the cylinder. A beta engine in which the power piston is not mounted coaxially with the displacer piston but in a different cylinder. This voids the complications of the displacer piston linkage passing through the efficiency. Theoretically, Stirling engine efficiency is equal to Carnot efficiency. Unfortunately, working fluid or gas is not ideal. This causes the efficiency to be lower than Stirling engine efficiency depends on temperature ratio, which is proportional, pressure ratio, inversely proportional, specific heat ratio, inversely proportional. Pros and cons. Pros. Various heat sources, environmental friendly, heat is external, and the burning of fuel air mixture can be more accurately controlled. Operates at relatively low pressure and thus are much safer than typical steam turbines. Less manpower needed to operate any type of commercial Stirling engine. Cons. Complex design due to regenerators, heaters, and coolers. Needs a large amount of cooling water which increases the size of radiator. High cost. Requires blower which reduces engine efficiency. Applications. Water pump stations. Combined heat and power plant. Solar power generation. Stirling coolers. Heat pump. Marine engines. Nuclear power. Aircraft engine. Why Stirling engine? Because it's best teaching and learning for any engineering students device, especially in the field of thermodynamics. Unique technology, an innovation with hundreds of applications. an innovation with a mission to save the Earth. Fuel and